You're watching Ham Radio Perspectives. Once again, I'm Quinn, K8QS.
And once again, I'm Tom, WA9TDD.
And we're talking about baluns, not un-uns. We'll talk about un-uns in another video, but baluns, balanced to unbalanced. How do you connect something that's a balanced, let's say, antenna to an unbalanced feed line like coax? That's what we're talking about, baluns. We're going to talk about 4 uses of a one-to-one balun, and we'll explain one-to-one balun means. But I want to start out, Tom, with the stories of olden days when you and I were in Chicago creating all kinds.
Baluns? What baluns?
What's the? You got it. You rascal, you got it. We had no idea what a balun was for. So we were putting up all these dipole antennas, fed in the middle and an equal on the side, just a straight old balun, like a 40-meter one that would be, how long would a 40-meter, or rather antennas, how long would a 40-meter antenna be off the top of your head, Tom?
66 feet.
Oh, you rascal. Okay, so at 33 feet, right in the middle, we feed it with coax, because that's what everybody was using when we were growing up in Chicago, coax. You just take that coax and you figure out a way to solder the outside of the coax, the shield on one side, and the center to the other. And we would do this real cheaply, but at any rate, that was it. Put it up, run it, no problem, man. We're getting out like crazy. Who needs a stinking balun when you've got a balanced antenna? It's equal on the two sides, and you got coax, which is not equal. So in the olden days, Tom, right, with these big antennas you'd see for radio stations and everything else, they would have these dipoles up there, but they would feed them with ladder line, or today we would say window line. So this is what that kind of stuff looks like right here. You can see it in the image, and it's balanced. It's not like coax that has the center and then the outer shield. So, Tom, let's get into this right away. Specific situations where a one-to-one balun is highly recommended. Number 1, Tom.
Number 1 is connecting the coax, obviously, to a balanced antenna. A dipole is inherently a balanced antenna, and coax isn't. Actually, coax is 3 wires.
Right.
Yeah.
Oh, that'll throw people off.
That'll throw people off. The most common scenario is feeding a perfectly balanced antenna like a standard center-fed HF dipole or a Yagi with a standard coaxial cable. Now the coax is unbalanced. The inner conductor and outer conductor shields carry the signal differently. Dipoles are balanced. Both halves of the antenna should ideally mirror each other electrically. A one-to-one balun is the bridge between these two, ensuring that transition doesn't cause electrical imbalances while maintaining the 50 ohm to 50 ohm match.
There you go, Tom. So 50 ohm to 50 ohm, you want that. When you start to get differences between your antenna impedance and your feed line impedance, you start creating SWR, standing wave ratios. And it can get pretty bad depending on what you're doing. But the basic purpose here is so that both are 50 ohms. And so you put that coax through a one-to-one balun at the antenna, right, the feed point of the antenna. So that's the first basic use of a one-to-one balun. And just to go back on one thing you said, Tom, about the 3 wires in coax, we've got the center wire that just acts as a center wire, but then we've got the shield, and the shield, inner part of the shield and the outer part of the shield act a little bit differently. So that gets us into number 2, when to use a one-to-one balun, and that is choking common mode currents. Common mode currents, that is keeping RF out of the shack. So we got RF going up the feed line to the antenna, and some of it's going to come back down if we don't have a good match. But even if we have a good match, still some of it is going to come back down. That's the nature of the beast. So when you connect coax directly to a dipole without a balun, sometimes a lot of the transmitted radio frequency, the RF, energy can flow back down the outside, that shield portion of the coax, toward your transceiver. So you got RF not only going out to contact people, you got it coming right back down. And it is not fun. So a one-to-one current balun, that's the thing here that's important. You're using a one-to-one current balun, not a voltage balun, acts as an RF choke, stopping this from happening. Using one prevents things like RF bites. When I used to use a metal, we weren't using baluns, and I had a metal microphone. I can't remember the manufacturer, Turner, I think. And I'd get too close to that metal microphone, and bzzz, I'd get a little zip on my lips, like a burn, or shocks from your radio chassis, and so on. This is what you get. That's RF coming back down. Nasty stuff. Can also get in all other parts of your equipment that are attached to your transceiver and cause all kinds of grief, even the computer. So RF interference from causing interference to what? Computers, USB devices, other electronics in your shack to act erratically or disconnect from transmitting. And for me, even, Tom, if I would run an amplifier with higher power, it would get into the house electrical circuit. And so my LEDs in the ceiling in the family room right next to me would start going on and off like an old psychedelic light show with, that we used to prize in the 60s and 70s. As I would speak, it would go on and off. My wife would say, "Hey, Quinn, you're interfering again," and of course that's from that RF coming down and getting into things. So that's the second reason to use the choking common mode currents. Make sure it is a current balun to stop that stuff.
And number 3, most important reason, is to preserve the antenna's radiation pattern. If RF travels on the outside of the coax cable, the coax essentially becomes part of the radiating antenna, and this skews and distorts very carefully planned radiation pattern. A one-to-one balun ensures that the only antenna elements are radiating the signal, keeping your transmission pattern predictable and pushing your power exactly where you want it.
Right. So when you look at various drawings with computer modeling, like this one right here, of what a dipole does and where the power goes and so on, these are ideal, all of these drawings. So don't assume, if you're not using a balun, that the way your antenna is working, pushing out the power primarily broadside on either side, like this shows, is the way it's working. It could be all kinds of cockamamie things going on if you don't use a balun to preserve the antenna's radiation pattern. And fourth, the use of a good current balun will reduce the receive noise. We're not talking about the noise caused by other stations near you, QR Mary as they call it, but we're talking about QR Nancy, a kind of atmospheric and electrical noise and all. Coax cables running through a house often pick up electromagnetic noise from household appliances, monitors, and switching power supplies. If the outside of the coax shield is electrically connected to the antenna's feed point without a balun, that local noise travels right into your receiver. A one-to-one balun chokes off that path, often lowering the noise floor and helping you hear the weaker stations. And Tom, we just did a video with Bob at Palomar Engineers about adding a one-to-one noise filter, which is a balun, a one-to-one noise filter at the rig itself. And I'm going to put a link in the description so you can take a look at that and see. That's another thing that you can do as well if you've got a lot of noise coming in. So you'd have one way of reducing the noise at the antenna and then one at the rig as well. When should we not use a one-to-one balun, Tom?
Well, that brings us to the point of when not to use a balun. And if you're building an off-center fed dipole, an end-fed half wave, or even a random wire, the impedance at the feed point will be much higher than the 50 ohm coax. In these cases, you need a step-up balun or an un-un, such as a 4-to-1, 9-to-1, 49-to-1, even I believe there's 52-to-1 to transform the impedance. It's usually used in conjunction with your antenna tuner.
Yeah, that's exactly right, Tom. And so when you start making your own antennas, think about this. Look up what kind of antenna you're working with and check out what the best balun is. Some of the best balun companies, unless you want to make your own, and it's you can make your own baluns cheaply. But when you get to the age that we are and the way our fingers are, winding the wire around these toroid donut holes is a pain in the rear. But that's basically what you have to do. And if you're not running a lot of power, buying a commercial balun is not expensive. It's when you get into the high power stuff that's more expensive. So this has been a little attempt by the two of us here at Ham Radio Perspectives just to shed a little light on one-to-one baluns and admit that for a number of years, we didn't know what they were used for exactly, what the word balun, balanced, unbalanced meant. Now I think most hams know that. But even with a dipole, you can make it work without a balun. But as we said here, you're going to get into some trouble if you don't do that. Thanks for watching. Please give us a thumbs up if you like this. Put some comments down below, maybe some helpful comments, anything you think we got wrong or other information to help viewers. We really like the community here on Ham Radio Perspectives. Thanks so much. I'm Quinn, K8QS.
And I'm Tom, WA9TDD.
73, everybody.